We are going to solve real-world problems using proportions. So let's start with the first problem. On Saturday morning, you cut 3 lawns in 5 hours. Your friend cut 5 lawns in 8 hours. Who cuts lawns at a faster rate? To figure this out, we can make a proportion, but we're going to need to find the unit rate of speed for both you and your friend. So let's start with you. We know that you can cut 3 lawns in 5 hours. So that's going to be your first ratio, 3 lawns to 5 hours. We're going to make this a proportion by setting it equal to another ratio. We need to know your unit rate of speed, so we need to know how many lawns you are going to cut, and since we don't know that, we're going to use the variable x to represent the number of lawns you can cut, but we need to know how many in 1 hour. Now you notice that since lawns were in my numerator on my first ratio, lawns are in the numerator for my second ratio. Again, hours were in the denominator for my first ratio, so hours are in the denominator for my second ratio. To get from 5 to 1, I would have divided by 5. 5 divided by 5 gives me 1. That means that to get from 3 to x, I would also have to divide by 5. Well, when I divide 3 by 5, I know that I'm not going to get a whole number, but instead I'm going to get a decimal. That means that x, when I divide 3 by 5, is equal to 0.6. This means that you can cut 0.6 lawns per hour. Now let's look at how many lawns your friend can cut. Your friend can cut 5 lawns in 8 hours, so that's going to be our first ratio, 5 lawns to 8 hours. We're going to set that equal to another ratio, where again we don't know how many lawns, so we use the variable x to represent the number of lawns, but we need to know per hour, so that's 1 hour. Now, to get from 8 to 1, we would have divided 8 by 8. So to get from 5 to x, we would also have to divide by 8. Well, when we take 5 and divide by 8, we would once again get a decimal. And when I do 5 divided by 8, I get 0.625. So that means that your friend can do 0.625 lawns per hour. Well, you can do 0.6 and your friend can do 0.625, which means that although your numbers are very close, your friend cuts lawns at a faster rate. Next, Daria and Quinn are delivering menus for a restaurant in their neighborhood. Daria delivers 350 menus in 2 hours, while Quinn delivers 510 menus in 3 hours. Who delivers menus at a faster rate? Well, again, we need to know how many menus per hour each of these people can deliver. So we're going to look at Daria first. I know that Daria delivers 350 menus in 2 hours, so that's going to be my ratio that I use, 350 menus to 2 hours. I'm going to set that equal to, I'm going to use the variable x for the number of menus, and then I know that I'm looking for however many menus for just 1 hour. So to get from 2 to 1, I would divide by 2, which means that to get from 350 to x, I would also have to divide by 2. When I do 350 divided by 2, I get 175. So x is equal to 175. This means that Daria can deliver 175 menus per 1 hour. Now let's look at Quinn. I know that Quinn can deliver 510 menus in 3 hours. So that's going to be my first ratio, 510 menus to 3 hours. What I need to know is how many menus, so I'm going to use the variable x to represent that, she can deliver in 1 hour. Now to get from 3 to 1, I would divide by 3, which means to get from 510 to x, I would also divide by 3. When I do 510 divided by 3, I get 170. So x equals 170, which means that Quinn delivers 170 menus per hour. So when I compare, Daria can do 175 menus per hour, while Quinn can only deliver 175 or 70 menus per hour. This means that Daria delivers menus at a faster rate. Which runs faster? A cheetah that can run 60 feet in 4 seconds, or a gazelle that can run 100 feet in 8 seconds? So if I look at my cheetah, I'm going to find its unit rate of speed. I know that the cheetah can run 60 feet in 4 seconds, so that's going to be my first ratio. And in this case, I need to know how many feet. So I'm looking for feet, and I need to know in how many seconds instead of how many hours. So 4 seconds is going to be changed to 1 second. Now, to get from 4 to 1, I would have divided by 4, which means that to get from 60 to x, I would also divide by 4. When I do 60 divided by 4, I get 15, which means that x equals 15. So the cheetah can travel 15 feet in 1 second, or 15 feet per second. Now let's look at the gazelle. The gazelle can run 100 feet in 8 seconds. So that's going to be my first ratio. I'm going to compare that to, I don't know how many feet, so I'm going to use x, and I'm looking for per second, so 1 second. Now to get from 8 to 1, I would divide by 8. So to get from 100 to x, I would also divide by 8. When I do 100 divided by 8, I'm not going to get a whole number. Instead, I'm going to get a decimal, but I get 12.5. This means that a gazelle travels at 12.5 feet per second. When I compare the cheetah, which travels 15 feet per second, to the gazelle, who travels 12.5 feet per second, I can see that the cheetah travels faster. A secretary at a law firm is able to type 225 words in 3 minutes. A computer teacher is able to type 105 words in 90 seconds. Who types at a faster rate? Before I get started, I noticed that both of these people are using words, but my secretary is using words per minute, and my computer teacher is using words per second. In order for me to be able to accurately compare these, I need to use the same method of measurement. So I can either change minutes to seconds or seconds to minutes, but both people need to be using the same measures. Since it's easy to change minutes to seconds, I'm going to change 3 minutes into seconds. And I know that there are 60 seconds in 1 minute. So to get 3 minutes into seconds, I would do 3 times 60, which would give me 180. So 3 minutes is the same as 180 seconds. Now that I know that, I can compare the secretary to the computer teacher. So the secretary types 225 words in 3 minutes, but I know that 3 minutes is the same as 180 seconds. So the secretary types 225 words in 180 seconds. I need to know how many words, so I'm putting X for the number of words, she can type in just 1 second. Now, to get from 180 to 1, I would divide by 180. So to get from 225 to X, I would also divide by 180. When I do 225 divided by 180, I get 1.25. This means that the secretary types at a rate of 1.25 words per second. Now let's look at the computer teacher. The computer teacher types at a rate of 105 words per 90 seconds. So 105 words for 90 seconds. I need to know how many words, so X to represent the number of words, the teacher can type in 1 second. To get from 90 to 1, I would have divided by 90. So to get from 105 to X, I would also divide by 90. When I do 105 divided by 90, I notice that I actually get a repeating decimal. I get 1.1 and then 6 that repeats. So I can use my bar to show that the 6 repeats. So the teacher writes approximately 1.16 repeating words per second. Now, when I look at which person types fastest, I know that 1.25 is faster than 1.16. So that means that the secretary types at a faster rate. A striped marlin can swim at a rate of 70 miles per hour. Is this faster or slower than a sailfish, which takes 30 minutes to swim 40 miles? Well, we don't have to find the unit rate for the striped marlin because we already know that the striped marlin travels at a rate of 70 miles per hour. So to be able to compare it to the sailfish, we need to find out how many miles per hour the sailfish can travel. Well, when I look at what the information that they give me for the sailfish says, it says that the sailfish travels 40 miles in 30 minutes. Well, I need to change that to hours so that I can compare it to my striped marlin. I know that if I have 30 minutes, there are 60 minutes in 1 hour. So 30 minutes is the same as 30 divided by 60, or 0.5. So 30 minutes is the same as 0.5 of an hour. So for my sailfish, if I want to find the unit rate of speed, I can say that my sailfish will travel 40 miles in 30 minutes, but I know that 30 minutes is the same as 0.5 hours. I'm going to set that in a proportion where I'm looking for how many miles my sailfish can travel in 1 hour. Now, to get from 0.5 to 1, because 1 is actually larger than 0.5, for this I would have had to multiply. So to get from 0.5 to 1, I would have multiplied by 2, which means that to get from 40 to x, I would also multiply by 2. 40 times 2 gives me 80, so for this, that means x equals 80. And that means that the sailfish travels 80 miles per hour. Now the question asks, is my sailfish, or is my marlin, faster or slower than my sailfish? If my marlin travels 70 miles per hour and my sailfish travels 80 miles per hour, then my marlin is slower than the sailfish.